not, y'all are exactly right. I said which of the graphs, right? So it's actually both option 2 and option 4.
It only
okay?
let you pick one answer.
It did? That was it?
It only let you pick one.
So y'all are all right. Yeah, y'all are good. But it would actually be both because you can't have a break in a graph of a polynomial. You also cannot have something that comes to a point. So a polynomial is something that has like a power, right? It has to have a power, and it's continuous, meaning it has no breaks in it, and it's going to have curves that kind of go up and down. Is a quadratic a polynomial?
Yes.
Yes, it is. It's actually a polynomial for sure. So that's just an example of the introduction to our polynomial on this side. Does anyone know what, let's say this, option 6, if you could tell me what the equation would be, or what degree of this polynomial option 6 is, I've got 4 tickets for you. Raise your...
Third.
X to the what?
Third.
Why?
Because there's like, let me say it. I'm trying to say it, but
Good, I got you. Olivia, do you know what other ones would be x to the third?
X to the third.
Other options? So option 6 is, right?
I don't know. 5.
5 is for sure, yeah, because it goes down. It doesn't quite go down and up like dip, but it definitely is. And then also, Jake, do you know the other one?
1.
Yeah, option 1 as well. Good stuff. And that would be where we be headed. Awesome. Give yourself a point if you got that one right. My apology. I thought we had it to where you could do multiple ones. All right, second one. What is a zero of a polynomial? Okay. A zero of a polynomial. I've got 0. I don't know. Can't remember. Yeah, it's an x-intercept or a solution. I will take that. That's actually pretty good. Who wrote that one? X-intercept or solution? Good job, Christine. It's exactly right. Okay. An x-intercept or a solution. Here's a bonus question. Okay. Hunter, how many possible zeros or x-intercepts, right? Same word. Does a quadratic have?
4.
4? Like, kind of. I think I know what you mean by that. So it has 2 because it's an x, y, right? So kind of 4 numbers, but 2 sets that are possible. What's another possibility for a quadratic? The amount of zeros. 1 or 0. Yeah, it's possible to have 0 as well. Nice. All right, next one. Give yourself a point if you got that there. Let's go to the next one. How many zeros does the following polynomial have? If you didn't know the previous one, this might have been a little bit tricky. Diego, do you know how many it would have now that you know the definition? It'd be 1. Good. Nicely done. Okay, so we've got 1 there. Here's a question. What would be the multiplicity of that 0? Say it again.
1.
Why? You're right, Mason. That's okay. We're going to get to that today. Multiplicity, that's the next word. You're not old enough yet, but by the end of today, you will be. You'll be old enough, okay? All right? Very good. What are extrema in a polynomial? I love to see these. Okay, I love that. Right here, 2, I don't know. Extrema. What's that? An up arrow? Who put the up arrow?
That was me, so I got it right.
Congratulate, Jake. That's good. Who put minimum or maximums? Those are extrema. Just a fancy word for either a minimum or a maximum, right? Minimum or a maximum. So if you hear extrema, someone said maximum point. Minimum or maximum is kind of what we're at there. Give yourself a point if you got that one right for you and your team. Let's go to the next one. X squared plus 10x plus 25. What are the zeros of the polynomial? We set it equal to 0. We factor, and what do we get as the 0? Someone raise their hand before I get there. Hannah? Yeah, it'd be -5. I think it's just -5 because it'd be x plus 5, x plus 5. Cool? All right, so question. X plus 5 times x plus 5, right? So how many -5s do I have? 2, right? Good, Rosemary. Rosemary, what's the multiplicity then? 2. Good. And we're going to head into that. If you're like, Coach, I'm not sure, we're going to get to that later today, okay? All right, we've got that there. Some people, thumbs down. This is hilarious. And there is Jake again with the arrow, and but it was incorrect. Your mom.
That question.
My mom's a nice lady.
No, that question was referring to the previous question.
Oh, hold up.
I read it out.
I just figured.
Did I mess up on this?
I think we thought that this was talking about like what the.
So this was the answer, right? So this was the answer. My apology. I went to the next question, so that's my fault. So this would be 5, right? So if you got put 5, you'd be correct. This one, and I think this was what we were saying, Katie, right? So this one would be the next one. What is the multiplicity? So actually, Jake was right. It would be 2 with the up arrow. Who put 2? Nicely done. Well, Jake kind of did, right? And I gave Rosemary some for putting that 2 as well. Good. All right. Is this helping? We're kind of going through, this is not a note format, but a little bit different. Is there a show movie that you would recommend? Okay, let's see. We're just going to spend like 2 seconds on this, all right? If you have not seen Bodyguard, I hear that one's a good one. If you haven't seen Broadchurch is a really good one. Murder Mystery, it's a good one as well. AP Bio, is that a show?
Wait, Coach Jay, what do you watch on? Like, what do you watch on?
Netflix, yeah. I have that Amazon Prime. We have Night Watch. I'm gonna keep these. Your mom? What? Jake, is that you?
No, that's fine. You just showed it.
Oh, he just gotcha.
Why would you?
Kim and me.
There we go, Hunter. That's a little weird, Hunter, but that's okay. And A Quiet Place. Isn't that a movie? Yeah, it's a movie. I hear that's a good one.
I hated it.
Hold up, was that the one with no words throughout?
Well, I mean,
I've seen
there
that
were
one. Very good. Okay, so how many of you in your group got all of them right? Raise your hand. You got all of them right?
No.
Y'all got all of them there? How many of you got missed one?
Oh,
Missed one? I think there was like,
we missed one.
was there 6 total like real questions?
We missed 5. We missed 1.
Y'all missed one?
We missed
You didn't count the arrows, right?
Technically. So we
You
got
count the
it.
arrows.
Well,
I got
technically,
Okay.
the arrows are both right.
Since we are a team.
It's for your mom.
It's a one-sided team.
We only missed 1 too as well.
Y'all did too?
Yeah.
Okay, so today we're going to fly through these notes, mainly because we've already kind of hit on them. Take out your notes and or homework right now, okay? If you need 2.2 notes, you lost it or something, I do have a couple extra in the back. I don't have a ton of them, but I do have 2.2 back there. It also was attached to 2.1, okay? All right, let's do this. Let's put up our phones. We're going to dial in now to our 2.2a, okay? I've already talked over this, so a lot of this stuff is not anything new. When we talked about this idea of a polynomial, remember a couple of things that has to happen. It has to be continuous. It can't have breaks in it. It also cannot come into a point, right? Can't come to a point. Awesome. Okay. As we look at this, though, here's the thing. The end behavior of a polynomial, okay? You want to write this down, okay? You want to write this down. When we get to the end behavior of a polynomial, we look at 2 things. So I'm going to give you an example. We'll say y is equal to 3x to the 5th plus 2x minus 3, okay? Just a random polynomial. One of the questions that I'm going to ask on the homework, you'll like this one because it's pretty quick, is what is the end behavior of this polynomial? Now, what happens in the middle, I don't really care about at this point, okay? We will later on. But at this polynomial, we're wondering, when it goes way to the left and way to the right, what is occurring? Is it up or down, okay? So here's how we're going to determine this. We come up with 2 different things. We have what's called a lead coefficient, okay? And I'll actually write this here. A lead coefficient and the degree. Okay? So we have the degree and the lead coefficient. Now, here are the possibilities. The possibilities of a lead coefficient is it can be either even or it can be odd. Okay? And the degree can be either, I'm sorry, backtrack with me. I meant to put this down here. The degree could be either even or odd, and the lead coefficient could be either positive or negative. That's my fault. So it could be positive or it could be negative. Okay? Now think with me for a second. If the lead coefficient is negative, meaning what's the lead coefficient? The number in front of the highest degree. Okay? If that is negative, then what we'd say is that it would both be going down both left and right. Okay? So what we would say is it will fall left and fall right. Okay? We good? Victoria, you with me? Okay? So it'd fall left and fall right if this is negative. Do you remember that with the quadratic? Now, if the degree is even, think of a quadratic there, it will rise and fall together. So let me say that again. If I have a quadratic, I'll put it up here, that's y equals 3x squared. Would they both rise or both fall? They would both rise. Why? Because what is the degree or the highest exponent of this one in white? 2. So it is even. So they'll both either rise to the left and right, or they'll both fall to the left and right. Does that make sense? Is the lead coefficient positive or negative? It's positive. So therefore, both will rise both to the left, and it will rise to the right. Okay? Does that make sense? Okay? So let's look at an example. If we look at this one, what is the lead coefficient, bless you, of this polynomial here?
Positive and odd.
Okay, so the lead coefficient would be 3, right? The number in front of
Oh.
the highest exponent. So the lead coefficient's there. What's the degree? Degree's 5. Good. So this would be my degree. Okay, so let's talk over this. It's positive, and what would be the degree? It's odd. Okay? When it is odd, think of like x to the third. It will rise and fall in an opposite direction. Does that make sense? Okay? So it could either be this way or it could be this way. Right? So in this situation, because of the fact that the lead coefficient is positive, we don't know what's going to happen in the middle of this graph, but what we do know is that we rise right and fall left. Okay? You say, Coach, why is that? Because it's odd. It goes in opposite directions. When it is positive, think of this as like a positive slope. Does that make sense? So like rise right and fall left. Okay? Rise right and fall left. Cool. All right, so these are the 4 possibilities. Can y'all see this? Is this hard to see for y'all?
Yeah.
A little bit? Okay. Let me do this. Yeah, what's up, Jay? You bet. Is that better or is that worse? Does that make it look okay? Makes it look a little better. So look at this one right here, okay? The end behavior of our first possibility is we fall to the left and we rise to the right, okay? In this situation, we have a lead coefficient that is positive and a degree that is odd, okay? Remember, the odds go in the opposite directions. Cool? All right? Devin and Victoria, can we put those down? Unless you're taking notes here, okay? Look at this one up here, the one that we rise to the left and fall to the right. What would be the lead coefficient, positive or negative? Negative, right? Look at the slope. Like, look, if I were to draw a line here, which I know it's not a line, but if I were to draw a line, it would be a negative slope, right? So think of this as the lead coefficient as negative. And what would be the degree here? Positive or odd or even?
Odd.
Odd, very good. When would it be odd? Or when would it be even?
If they both rose or fell to the same.
Yes.
Whatever.
Yeah. If it was even positive, it would go like up here. If it was even negative, it would go low, low, low. Okay? Cool. All right, so look down here. Someone tell me, what is the lead coefficient for this one?
Negative.
Negative. Good, David. And what's the degree?
Even.
Even. Nice. Okay? What about this one over here? Lead coefficient would be negative because they're going low, right? They're going low. And what about the degree? The degree would be even. Nicely done. So the possibilities are rise left, rise right, fall right, rise left, fall right, or fall left, rise right.
That
Okay.
last one, Coach Jay, I'm
Yeah.
like confused because like it like starts going up, but then it goes down. Like,
You're great question. Remember,
oh, you know, it's like
I don't care about the
yeah.
dotted stuff in the middle. I'm just worried about, remember, this is called the end behavior test, right? Or the lead coefficient test. So we're just concerned with what's happening at the farthest left and farthest right.
Okay.
Is that cool?
Yeah.
So you could literally put fall left, fall right. That's all I care about.
Okay.
Okay.
Fall left, fall right. Yeah.
Cool? All right, Hannah, could I ask you something? See if you got it. So if I come back to my example, y equals 3x to the fifth plus 2x minus 3, what would be the lead coefficient here? Good. And what would be the degree? Good. So what would be my end behavior? Good. So it's going to go opposite. Which one? Would it fall left, rise right, or the opposite? Okay, that would be, like if I went this way, that's a negative slope.
Oh,
Got me?
so then it's left.
Rise right. You'd say rise right, fall left. Cool? So how I would write this is rise right, fall to the left. Cool? All right? Again, don't care about what's happening in the middle, just what's happening on the extreme
So
sides.
basically, if we get an equation like that, we don't worry about the
Yep, that's just, it does not matter, right? It does not matter for this test, right? Just what is the highest degree and what's the coefficient in front of it, okay? All right, so to give you a little bit of practice, do you see your homework there on your homework side? I think I've got mine right here. Here's what I want you to do. Based off the polynomials, it's on this kind of side over here, the warm-up. Based off of the polynomials, I want you to match up the graphs with what the polynomials would be. Does that make sense? So you'll be able to see, use the end behavior, find what the end behavior would be, and then match them together. Okay? See if you can do that. I'll give you a couple minutes to kind of attack that. Go ahead, and then we'll go through them there in a minute. Okay? Awesome. Y'all need this up here? Keep them on this. All right, go right ahead.
Yeah, I'm sick. Let me spin your water in 2 days. If you're not sick,
Yes, ma'am? Let me get the lights for y'all. Yes, ma'am?
So this is going down.
So it's negative, right? What's the degree of that? Correct. So it's odd, and then the coefficient's negative. So it's the opposites, right? But as I look at it, would it be this way? Like if you're looking at me as the graph, would it be this way or this way? This way. Good. So how would I describe it? I would rise left and fall right.
Coach Jay, who's the game against tonight?
That actually would work, but then one thing we have to notice is just with one degree, would that be a
Same direction.
cubic?
It has
Or
to
would that be
rise left and fall left, right?
that?
Coach Jay,
Rise left,
I believe since it's positive,
fall left. So it's going
up right
Correct.
That's
That's
not possible. Rise left
That's
and
it.
fall right.
The reason why don't they both go up?
because
It's
it's not
gonna
the
be
what we were just working on. It's the to the fifth.
Good, because it's odd. So odd means they're going to be opposites.
Odd
Right?
means opposites. Okay. Right.
That's it.
Who's the game against tonight, Coach Jay?
Maris.
Start
Decent.
is
Decent.
They're decent.
Won't be it.
even or positive and odd. Rise right.
Get some
Sure,
more.
two of these are negative.
Great point. Yeah. So one of them is negative and even. Both of them are right. Negative and even. So what is the end behavior going to be for both of them?
So it should look like rise, left, fall, right.
Well, with even, it's an even degree. They go together. Okay. The one I remember all the time is quadratic, like if it's squared. If something is squared, they either will both fall low or they'll both rise high. Does that make
So
sense?
the negative even, they're the same?
They're the same. Would they both go up or they both go down? They both go down. Good. The difference is, how do I know the difference between the graph? Well, what two graphs could I eliminate or focus in on to know that it's got to be one or the other? Good. And out of those two, which one is a quadratic?
So it's right, yeah, so it's H, right? 'Cause it's
Correct.
rising.
And what equation associates to that? Good. Good. Does that make sense?
Any conversation?
How are you doing, man?
I don't really understand.
Yeah. Okay. Can I help you? So think of a quadratic, because that's the one we've already done. If it's a positive, if I say like y equals x squared, you know what's going to happen. They're both going to rise up or fall down.
So let's go rise up.
X squared. I'll write over here. If I said y equals
X
x
squared
squared,
rising up.
I think.
both would do what?
Rise could be.
Yeah, good. Y equals x squared, both would go, it would go up like this, right? So we would rise left, rise right. What if I did y equals negative x squared? What would happen here? It goes down. Good.
So
If I come over here, so that is where
odd.
these are even.
It's a
The difference is the lead coefficient is negative and the lead coefficient over
same
here is
direction.
positive. So if it's positive even, both rise. If it's negative even, both fall. Okay? Over here, when I do x to the third, positive, this is like a squiggly. It goes like this. Cool.
It's just rise, right, fall.
But when it's negative, it's going to do the opposite. So if it's positive on, think of like positive
So they
slope,
have to go in the same direction.
positive on, negative on. Positive on, negative on. So if it is a negative odd degree, then it will rise left, fall right. Right. Give me an equation maybe that just random.
Coach, what about one without a X one?
This might be easier than this one
So
here.
it could be.
So what is the lead coefficient?
This one?
Like number one without X one?
Good. What's the degree?
Oh, it's
Good. So it's an odd degree, which
Sorry.
tells me that is it gonna both rise up or be different? Good. And would they
I don't
go
even know if
like this or like this? Yeah. So you'd say rise right, right here, rise right, and then fall left.
Where do you sit?
I'm a business.
In the middle stuff, great question.
Sorry.
We're not really concerned with that yet.
This has the
And really, those are pretty high where
right back in the
I
back
don't know if I'm
left.
gonna have you grasp
Describe
all
what
of
happened.
that time. So it's more just knowing the end behavior, like where is it gonna head? I know at the end on the right is gonna rise, and at the end on the left is gonna fall. The stuff that's in the middle right here, I don't know. I don't know what's in here.
What about these graphs that are like?
She's very smart.
So if it's negative,
Good question, but
I
I
don't
would
understand. So if it's negative, that's what?
what would be
Which way, the right way?
two, what's the lead coefficient? Is it
It's
positive?
negative.
Good, so would they both, like, where would be the interchange on
It's
that?
left, left, right, falls.
Means like at the very end points, again, not focused on the middle,
If
but like right over here, what's gonna happen at the very end of the right? It's gonna rise,
Are
right?
they really?
It's gonna
it's
fall
just that
over.
way.
So when your x squared is what's gonna be so it's gonna rise right and rise. So which one rises left and rises right?
So each starter is also on, like you're gonna go opposite ways.
But
Okay,
when
so
you go
which
to
we
the
did
x
with
squared,
negative
right?
and
Which out of
We
which
beat
There's one
Who is
negative,
leading?
so negative means that one's gonna go down.
Does that make sense?
Yeah.
So you're just kind of playing.
My dad
what is it?
negative
So,
Just
we
even
lived in
means it's the same way.
Cincinnati.
But negative means down, so they're both the same.
Five or
even
I
means
thought, like, my sister was born in 2004.
if it's to the fourth, right, that means it's even. They're going to go together. And because the lead coefficient is negative,
So it's 1, 2, 4.
I
think that's
exactly right.
Okay.
So this would be,
or positive.
that's a new question. Right now you don't have to. Just know the end behavior, right? That's how I can pick it out. Cool? Okay? So we do it.
And then negative is down or left is right.
Anybody know what's
It's like it's so small. Like, I had everything I needed. I just walked right. It was like my neighborhood. It was like my neighborhood right here. It was like the neighborhood like no, I was born in Colorado.
Yeah, so just so you're aware, I could multiply this negative one by this. Got me? So just take this one.
I lived till
What's the negative, right? So they're gonna do the same or different?
I'm gonna grow up. I'm
Different is
later on.
rise to. I'm sorry, I always do it this way, like this. Or like this.
Oh.
So rise left and fall left.
Oh god.
Really like Walmart right here. Just like jump zone, TCBY.
Are y'all okay over here?
Sports. There's like a little chain right here. TCBY.
Fairly? Remember too that we're not as concerned with what happens in the middle, right? Other than quadratics, because we know those. We're only concerned with the end behavior. So these funky ones right here, you're just trying to play like elimination. You're trying to eliminate.
And this is like a road right here. And it's like here's what never. I love like
Good job.
it was like I would ride my bike.
Okay, hey, let's do this real quick. You got something?
I really the exact route. I can pick it.
There's a way you like that.
I was in first the whole time. And then like at the last stretch, this kid passed me. Like,
We're gonna move into that phase on. We're almost there. Hey, Jack wanted me to do one on the homework real quick. We've got right now, I think we've got about 8 minutes or so. So I wanted to, Jack had one off the homework that I want to start going into. Question, I mean, I think a little practice will do us good on these. Do you start getting it a little bit? The idea? It's more, you've just got to feel it out. What I would do is I would put this on the note card for Tuesday. So put the rules on there. Hey, when it's a lead coefficient that's positive and it's odd, or positive and odd, what happens, and so on and so forth. Just get the rules down, and that way we can continue to be familiar with it. Go to the back side of that first page of the homework, and we can we're going to go into the one that Jack brought up, which I thought was pretty good. Okay. All right, Jack, could you give that to me, because we'll go off script just for a little bit here.
Y equals 4x cubed plus
4x cubed plus.
4x squared
Yep.
minus 8x plus 8.
Okay, we're going to talk about what are zeros, how do we find zeros, and what is multiplicity, okay? Which we'll use a homework problem to kind of attack it. That way we're kind of doing two things at once. First thing, can I take out a GCF? 4, okay? And in fact, before I even do that, with a 0, we're finding an x-intercept, which means we're plugging 0 in for y. You remember that? Kind of off that quadratic. So 0 equals all of this mess here, okay? I like what Jack had said in terms of taking out a 4 out of everything. So now we're left with x to the third plus x squared minus 2x plus 2. Okay? All right, questions on that? Okay, any thoughts at all on how I can factor this? Is this plus 2? Is this right?
It is.
Right here? Okay. Look at this, because this might be. Keep going. Keep going. Question. Okay, there's 4 terms, right? So this is a little bit tough. Can I take anything out of the first two that's in common?
You can take it out next.
Yeah, well, so we're going to pull the 4 out.
Yeah.
I could take out an x squared, leaving me with what? X
X plus 1.
x plus 1. Very good. Okay. This next part might throw us off just a little bit. I would say take out a 2, right? So when I take out a 2, this is left with what? X minus 1. This is where, I don't know if maybe there's a typo there or something. Do this just really quick. Change it so that we can actually factor this and go. Change this 2 to a negative, because let's say that I took out a negative 2 here. That's in common. What does that change this to? X plus 1. Does that make sense? The reason why is these have to be the exact same. Okay? Does that make sense? But you're basically taking the first 2 and the second 2 and pulling out what's in common. So what's in common between this first one and the second one? Yeah, both are x plus 1s. I like it. So we can just have an x plus 1 times x squared minus 2, and then just don't forget that 4 on the outside, okay, that we had pulled out from the original one here. So we have 4 times x plus 1 times x squared minus 2, and it's equal to 0. So what do I do in order to solve for the zeros that are here? Set them equal to 0. Yeah, great job. So does that make a difference? The 4? 4 equals 0 does nothing, right? Because I can't solve for that. What does x plus 1 equal 0? Negative 1. Good. So we would say that x is equal to negative 1. That's our first one. What about x squared minus 2?
It's going to be 1 and 1, so it's just 1.
Why?
That was confusing.
Good. You went after it, though.
Coach Jay, you're wrong.
Yes, you're all over it. So we're going to have to square root it eventually, right, Hannah? So up here we've got x squared.
All you got to do is factor x2 minus 2. I'm right.
Gotcha.
Good job, Jake.
Very good. Good job, Jay. So I think we're on top of this here. I think we're good. So we could add 2 to either side, right?
Or you can do that, but I mean.
And then what do I do to get x by itself? Square root it. Square root is squared, and we get x is equal to. Good. Square root of 2. I like it. And it's also plus or minus square root
It's wrong.
of 2. Okay?
It's wrong.
All right?
X squared minus 2 is 1.
I'm confused. I'm confused.
Never mind.
Okay.
You can keep going.
You got it, though.
Yeah, but I think I deserve a ticket for participation.
This is true. You have participated today. You have. I've got you. Got you. All right. When we look at the zeros, right, how many zeros do we have?
3?
3, right? So we have 1, we have 2, and then 3 with a plus or minus. Question. What is the multiplicity of negative 1? Good. You want to put that down. Multiplicity of 1. You say, Coach, what's multiplicity? It's the amount of times it repeats. So it has a multiplicity of 1 because there's only one time it repeats. What about for up here? 1? Yeah, I just put m of 1, but multiplicity of 1. Same thing up here is the multiplicity of 1 for both positive and negative, right? So square root of 2 and negative square root of 2 are 2 different things. All right? Now, I will give you 6 tickets if you could tell me, what does multiplicity have to do with my graph?
How many times is it?
Okay, I think you're onto it. Say again, Rosemary. That's close. So how many times will it hit the x-axis for this one? Negative 1, square root of 2, and negative square root of 2, right? Say that again. No, you're on it. You are on it. Does anyone else want to build on what Rosemary's saying? Gotcha, Christine. Bingo. All right, stay with me because Christine's right. If it is even, it will bounce off the x-axis. So if it's an even multiplicity, it will touch and return. If it is odd, it will cross. Okay, it will cross. We'll hit that again a little bit later. Great job today. Good work. Christine, good work today. Christine wrapped in the tickets today. It means the amount of times that zero repeats. It's only 1. Could I give you an example when it's not 1? That might be helpful. So if you said x plus 1 squared, right, times x minus 2, and this was what we factored. Okay, let's say we factored this. What are my zeros?
-1 and 2.
Good. What is the multiplicity of -1?
I don't know.
There would
How do
be
you find
2
it?
of them.
Oh, okay.
Because there's 2x plus 1s, right? So it repeats twice. What's the multiplicity of 2? Good.
So you find it by the exponent?
The exponent, or sometimes it might not be the exponent because it could be
Okay.
it just could be there twice,
So it's
right?
from the original equation, or
After it's factored, right?
so
After it's
this
factored.
one?
Correct.
Okay.
Correct.
Is it all one?
And so on this one, just so you know, Olivia, because this might help you when you're doing it, -1 and 2 are my 2 zeros. Since this has a multiplicity of 2, when the graph hits the 0, it'll return. Because
Okay.
it's an even multiplicity. But since this is an odd multiplicity, when it hits this 2 over here,
It'll
it's going to go
bounce.
through.
So if it's even about